Static code analysis is a fancy term for looking for problems in the software program source code. If you have access to the source code for a program, you can check it directly for security problems using source code vulnerabilities analysis tools or by using your eyes and brain together. These methods for discovering programming errors in security are known as white box testing or clear box analysis. So, what is a source code? So, source code basically is an instruction describing what a computer program can potentially do, and which state analysis looks at the source code files, uh, but not program running in the memory, and the input data controls what program does while the code is running, and what data will the program receive as input. So function, method, procedure, APIs. So function contains all the code in a program. So the functions are basically the internal core to the program, and which is the reason why functions are typically accessible from the code of the program, and RPC can be accessed from outside of a program, and API exposes a program to other program, which helps the procedure of a function and APIs. So improper coding and use of function can create a buffer overflow condition, like there will be three categories of buffer overflow condition to safely function, such as the first one is the function easy to use safely is basically the safe way to use the function, and the function easy to use unsafely is basically the hazardous, which is not recommended, and function impossible to use safely is very dangerous for to use. And so we should throw away all that ancient and legacy code and rewrite the code so that we can write the function safely for everyone. So here are some of the safe and unsafe functions. So the left hand side there are the some unsafe function, and which they call the banned function, which is usually the get, stir, copy, stir and copy. And for the opposite case, the safe function equivalents are just the difference is between the underscore s and every cases. So it's better to use the safe function equivalent rather than the unsafe function. So example of a unsafe function which is sure to avoid, like in this case code is very easy to check whether your password here is within the code, so anyone can check the password within its code. But our functions are really safer, mostly yes, because nowadays they use safe coding, and developer use the boundary checking input or parameter validation, and the static code analysis find cause to unsafe function, and the compilers warn of and even replace unsafe function so that they safely to use and compile. So boundary checking. So for the boundary checking, the index value is 0 to 9. So code and data has boundaries. So boundary is 0 to 9 and stay within the boundary. So if we check like buffer 5, so it is it is the within the index value, so it is good. So if buffer is 10, then it is bad, so it is a risk overflowing. So never forget to check the boundary, and always use the index value and use the inside the index value. So parameter validation, so I mentioned that input validation performed aside of a function is called parameter validation. This is because data is passed to a function in the form of function parameter, and in this code of example we can see a tiny C program that contains the two function parameter, which is argc and rb. So this program displays the value of a third element in the argb contents, so arbitrary array, which is the second argument passed to the program on its command line. So if we run this program with the following command line argument, the strength R2 would be displayed. So the problem here is that there is no parameter validation before the art where the array is used, because the program can be run with any number of command like line argument or including only one or none could attempt to display an argument value that doesn't exist, and that would be bad. So let's look back at the how to fix the problem using parameter validation. So here is the same problem. So we have written the secure coding practices in mind. First, we check the program was run within the command line, and that contains at least two arguments. If this argument's value is greater than 1, then the operation system is telling us that there is at least 3 arguments in the RB array. So next, if we check the third array element actually contains data. If it does, we check the data is acceptable length. If all those validation checks are true, then we can call the printf function to pass to it the value of the second command line argument to display. So if you see the parameter validation in the same thing as input validation, we are simply checking if data passed as input to a function is acceptable before we use it. Is just a common sense, right? Is also a lots of extra code which many programmers like us don't do it. So the next, the format string buffer overflow vulnerability is caused by the lack of input validation or parameter validation. It occurs when a formatted print function is passed and a format string using a variable rather than using a hard-coded concept, which is by far the most common way to construct a formatted print statement. So if you are a C programmer, you are looking at this two codes example and probably saying to do the exact same thing, or is the big deal. But well, let's have a look at the code in the another context. In this one, unlike the previous one, the two variables used by the first two printf are parameters passed and parameter passed to the function, and you guessed it, there is no parameter validation being performed. So which is these two function calls is most likely to have a buffer overflow condition. So yes, the first one, this is because of the form at a string passed to the first printer function as a parameter is not being checked. If it won't result in something dangerous happening, if an attacker should find a way to control this input data, it could result in displaying internal memory address or corruption of data, or just crashing the program pass format string and variables. So if you must, but always check if the data is correct first.